All right. Let's look at current events. Let's take a peek. Okay. So today is the 24th of December. Why does my phone make that weird noise? Why does my phone make that weird noise? That's what I want to know. All right, so let's see. I'm just kidding. I'm just messing with the AI. Who don't use autocomplete LSP. How do you do it? Yeah, okay, so that's interesting. So like when I did C Sharp, I was always using Visual Studio, and the IntelliSense was really good. When I was doing Java, I would always use IntelliJ, and the IntelliSense was really good. But when I was doing like Python, for example, I did Python like, I guess this was when I was a hobbyist, so it probably doesn't count. But I would always just type it into the Python console, and you didn't really have IntelliSense there. And it didn't feel like it was needed because you just put something into the console and get instant feedback, right? So it's a little bit different. Let's see what they say here. And then I would just use Jedit. I would literally use gedit like the meme. Because I didn't know Vim. To be honest, at that point, I didn't even know of Vim. I don't think I'd heard of it. So is this just... Does it not link to anything? I am totally fascinated by programmers who don't use many of the IDE features I take for granted today. Autocomplete language servers and recently Copilot. Interesting. Copilot goes pretty far beyond, or at least when I tried it, it went pretty far beyond what these do. This would tend to like generate a lot of code at once, which I think is pretty different. Do you just remember every type and field in a code base? To some extent, I think folks do, actually. Cannot live without the language server go to definition feature. What do you do if you need to look up the definition implementation of some function which is in some other file? So, I mean, my naive answer is they maybe just grep. I think a lot of people are just accustomed to just grepping all the time. And I think that that can work fine. Let's see if somebody says that. Just grep all the time. There are a lot of mentions. Have grep. Oh, there's a lot. There's a lot in here. What the heck? There is a lot of commentary. Okay, I'll star this. That's interesting. Let's go to Exorcism and pick up where I had left off. So, let's go to 48 and 24. And we were supposed to go to Knapsack JQ next. So let's give it a shot. Let's paste that. Okay, so we already got it. So let's go to Exorcism, JQ, Knapsack, and let's see if there's anything in there. Did I put something in there already? Nope. It just says def capacity. Okay, so let me remind myself of what we did for the other one. So the other one was colats, and I think the approach is going to be broadly kind of similar. So this is what we did. We had def steps. If dot less than equals 0, then only positive integers are allowed. Halt error 1. Fair enough. Else recursive steps, and we pass in a dot, and we pass in a 0 because we're going to make a count. All right, so then in the recursive steps, we get a number and an iteration number. If the number is less than 2, then we return whatever we were passed in. Or if it's even, then we divide it by 2 recursively, right? And we increment the increment count, right? So pretty straightforward. The knapsack has a little bit more going on, but it's going to be overall pretty similar to this. So let's look at the knapsack README. It has a little bit more going on. It's still pretty simple. So your task is to determine which items to take so that the total value of his selection is maximized, taking into account the knapsack's carrying capacity. Items will be represented as a list of items. Each item will have a weight and value. All values given will be strictly positive. Nice, nice. Bob can only take one of each item. This is good because, like, if a value was negative, then who knows what we would have to do. We would get into a mess, right? I mean, my first thought is that we would probably have a check and say, oh, hey, only positive integers are allowed. But whatever. So for the above, the first item has weight 5 and value 10. The second item has weight 4 and value 40, and so on. In this example, Bob should take the second and fourth item to maximize his value, which in this case is 90. So he took this one, and he didn't have room for anything else because there's nothing with weight of 2 or less. All right. Okay, so we're going to get something passed in as a JSON document, I think, right? So let's take a look at the test real quick. Okay, so let's run that first test. Make sure it's running. I misspelled it again. Okay, so we're skipping all but the first one, and for now, and the first one says no items, unexpected end. All right, so it's obviously not ready yet. But then let's take a look at what we're actually doing here. So we're passing in a JSON that has a maximum weight here, but no items for this first one. So now let's do our implementation. So we do def, let's see, capacity. So we're just going to get one JSON document passed in, right? So capacity, but we're going to have a recursive. So I'm just going to say rec capacity, I guess. Is capacity what's being called here? What does it say again in the test? It says JQ RF knapsack JQ end input. All right. So I don't think we actually want this. I think we just want the recursive one. So I'm gonna just call it knapsack, I guess, and it's going to get a dollar capacity, and it's going to get a dollar items, I believe. Okay, so then when we call it, we're going to call it with knapsack, and this is going to be maximum capacity, and this is going to be items, I believe. So I think it's as simple as that. Yeah, I don't think we need that. I think we can just do that. Okay, so if we look in the test, it was maximum weight and items. Okay, let me go fix it. Maximum weight and items. So, yeah, I like capacity better. Okay, so we're going to say, we're going to first filter So we're going to take $items array, select, and the item has a weight, right? Dot weight less than or equal to $capacity, right? And then it's going to be an if. Okay, so how did our if look before again? Let's look at this again. So we just did if, then elif, then else end. Okay. So that's going to be piped to an if. The if will have an end, and this will be if length equals 0. And then we're supposed to report the value, right? So we just pass back 0. Okay, so then I'm going to say here, else 0, but let's put in our comment. And did I ever learn JQ comment? I don't have a comment in here, right? JQ comment. Right here, right? Hash. Fill me in. Okay, so now let's try that first test. So compile error, expecting comma, unexpected comma, expecting semicolon. Yep, that's right. This has to be semicolon. Okay, is that better? Not yet. Unexpected square bracket on, let's see, expected format or QQ string start, Unix shell quoting issues. Unexpected invalid character. Which one is it? Expecting semicolon or this? Okay, dot weight less than equal $. Oh, yep. I did miss that. Yep. That's the kind of thing I should learn to not ever miss. Probably. Unexpected this. Okay, so now we did items. I think we do have to parenthesize this expression, maybe. Maybe. Or, I'm not sure I did this quite correctly. I think parenthesizing this, I think is fine. Unexpected ident. Oh, I never fixed that. So here, I had these guys indented. Okay, so unexpected. Knapsack maximum weight items. Oh, I need a semicolon, don't I? See, this is what I get for not knowing the syntax. Pretty relevant to that news item that was being talked about on Hacker News. Okay, so I think I must be almost there. Maybe? I'm not sure about the length. I don't think this is the problem. That can't be it. All right. Does it say the same as before? I think so. Unexpected this, which is this, right? Or is it this? Oh, I'm actually not sure there. Knapsack 1 is not defined at top level. Oh yeah, so this one has to be a semicolon. We're almost there, I believe. Okay, so okay, so that's that first one. Fun. Okay, good start. Good start. Loving it. All right. Phone making a strange sound. Check for interference, faulty charging port / cable connection, water damage, loose / damaged components, or overheating. So sure, that's a fine response, I think, from AI. Okay, so let's unskip that first actual test. So let us not skip this one. Okay, so that one did pass. Okay, fair enough, I guess. Okay, here we go. So now we're going to do this one. So we're expecting to get 21. So now we are actually going to do some of the work. So we're going to start to fill this in. So here we did go ahead and filter it already, right? So that's good. So I believe at this point, the dot should still refer to this filtered array here. We'll find out. So here we are going to do what? So basically for each item that we have in that array, we are going to recursively call knapsack with the capacity reduced. And oh, this reminds me. Let's see. Okay, let me just type it in. So for each item in the filtered array, we will add its value to the result of recursively calling knapsack with the capacity minus the item weight and the items that follow the item under consideration in the filtered array. So that's what we're going to do. All right. Kind of a mouthful, but that's what we're going to do. So I don't think I know how to do an action for each in JQ. I want to say, is it map? So if we map, we're also going to need to have a way to do a slice. So if we map, I think we need the index of what we're mapping. So let's take a look at the map here. And there might just be a for each, which would also, I think, be fine. In fact, I think it did say for each. Okay. We also might want reduce. Okay, so where's for each talked about? Reduce and for each. Okay, so here's for each, similar to reduce. Scoping. Okay, so reduce for each. Where's map? Because map is the one that I've actually used before, but I don't think map is the one that I want. It seems like reduce is most likely the one that I want. So let's take a look. The reduce syntax allows you to combine all of the results of an expression by accumulating them into a single answer. Yeah, sounds like a winner. The form is reduce expression as $var init update. As an example, we'll pass 1, 2, 3 to this expression. Reduce. All right, so we take everything from the array as $item. We initialize with 0, and then we do dot plus $item. Straightforward enough. So that's good. Now, so let's start filling that in here. So we're going to go reduce, and then we are going to take all of the items from that array, so same thing as they did, and then we are going to say as item, okay, and the starting will be 0 here again because we're doing something similar. So then we are going to take item value plus, so I guess let's start with dot plus because we are summing item value, and then here's the recursive call, right? Knapsack yeah, this is gonna be pretty simple once it works, I think. It's gonna look nice. So we're gonna put in capacity, subtract item weight, and then here we are going to do items slice, but we still need that index. We need that index number. We could consider this. It doesn't look like the best option. Shoot. Array object value iterator. Can we do keys? When keys is given an array, it returns the valid indices for that array. the integers from 0 to length 1, or to length minus 1, excuse me. So that's great. So we got 0, 1, 2. So let's use that. That will be great. So we'll do else reduce. So instead of this, we'll put keys, reduce keys as, so this will become I. This will become items, no. This will be dot sub $I. No, no, it's not dot in this context. If we can define a variable, which I believe we can, yes. Okay, so that's what we'll do. So we'll say as filtered items. Okay. And then here it will be filtered items $I dot value filtered items $I dot weight, and then here we are going to put filtered items $I slice, but I think this is +1 because we don't want the same thing in there again. Okay, so let's see, can I don't like how long this line is. Can we break this up? Well, let's see if it works first. No? Okay, so let's troubleshoot it, and then I'll see about refactoring to make it look nicer, if possible. So, this one still said, wait. So, 5 items cannot be greedy by weight. Let's see. Status 5 cannot index array with string weight. Okay. So that's what I tried to do here, I guess. Oh no, it was here actually. Was it? No, I think it's here. Filtered items sub $I dot weight. Yeah, I think I messed up that syntax. Did I do anything like that here? Not really. So I'm trying to take the item, filtered items $I, off of filtered items. No, I think this is wrong. I think keys, let's look at keys again. It gives back an array, right? So we need to get all the items from the array. Is that our problem? Does it say the same? Okay, syntax error, unexpected. This is kind of what I tried to do before, right? So we think it should be like this. And then we want to type. Is that it? Is that any better? Any different? No. Cannot index array with string items. Here? Is this where I tried to do it? Wait. Oh, right. No, does that make sense? Is that what it says everywhere? Cannot index array with string items. Line 16, no. Standard in 4, cannot index array with string items. I don't... It's a pretty clear error message. I just don't see where it's actually happened. Items. I don't see how it could be here. That's the only place I'm indexing something by string items, I think. The error message seems clear enough, right? But I don't know what it's actually referring to. I think when I see it, I'll be like, yeah, that was clear. Let me look at the reduce again. So for the reduce, can we define the reduce function separately? I'm not sure. Yeah, probably. Let's try it separately. So knapsack reducer, it just takes, well, it doesn't really matter what it takes. So then the knapsack reducer, we're going to move, so it's here, right? So it needs to take filtered items, and it needs to take $I, we think. So this dot cannot be correct. That's the first thing I'm seeing. Oh wait, yes, it probably is actually. I think this dot is supposed to be the ACK. Okay, let's see if this will work. Knapsack reducer, filtered items, I. Okay, so the reason I want to do this is because now I should be able to test out this knapsack reducer function on its own, I guess. Okay. So let's cat the knapsack. Okay, so we're going to echo just a couple of items, right? So it'll be value to weight 1 looks like that we needed to pass in the capacity as well, probably, right? I think I just really slurred my speech there. The capacity is referenced in the knapsack reducer. I guess it probably has to be passed in. I guess it can't really be tested by itself because it recursively calls the knapsack, right? So what the heck am I thinking? And also, okay, it just doesn't look right at all. Not even close. Let's go back and edit. Okay, so I'm missing that. Capacity needs to be passed in. Maybe I did find an issue there. Was there a parenthesis missing that whole time? I don't know. Let's see. Unexpected death? Okay, so I missed a semicolon. Nice. And then knapsack 2 is not defined. Okay, so we want to move... Oh, shoot. I guess this would have to be defined inside there. Is that any better? Okay, so now we're back to where I was. Cannot index array with string items. So items is an array. Or at least I thought it was. It's an array, but not in one of those cases. In this case, apparently it's empty object instead of empty array, but it probably doesn't matter. Because that one was passing. Cannot index array with string items. Darn, I actually do not know. Um, yeah, that's all it says. It seems like it must be misleading somehow. Or yeah, I don't understand it. Whatever it is, I don't understand it. So, oh, wait a minute. Is $I items? That must be what's happened. Okay, so select. Yeah, that didn't work the way I thought it should have worked at all. And I think I know why. Yeah, because I used dot here. That was never supposed to be dot. Or no, 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 no. Okay, I used items here. Uh-oh. Huh. Yeah, it sure doesn't look right. It was supposed to just be this. So I think I actually maybe don't want that part. Is this better? Cannot index array with string weight. Oh, okay. Yep. No, that still doesn't look like what I expected. It was supposed to be just the items, but everything is coming out. What the heck, man? Okay, so dollar items. Okay. So yeah, we can do it differently. We can just do knapsack there and define it here. And then this here can just be dot items. And then this becomes maximum weight. No, that's not right. The maximum weight is from before, right? There's generally a cleaner way to solve most problems in JQ than defining variables. And that's probably true in my case as well, but I probably just haven't thought of whatever it is yet, and I might not be able to think of whatever it is. So we do real names as $names. Then we did posts. This is exactly the kind of thing I'm looking for, right? So posts is here. So we did dot real names as $names. Store the real names object. But then posts was separate. So this is exactly what I'm trying to do here. And okay, yeah, this is very much, pretty much my exact situation. So it sounds like using a variable will make my life easier, probably, here. I don't know if it's exactly the same, but it seems similar to me. In this moment, it seems similar to me. So we're gonna go dot maximum weight as dollar capacity pipe, and then we are going to use the dollar items, or the dot items, excuse me, and then here we use the dollar capacity. Okay, so now yeah, let's try that. It's still putting out the whole thing. Oh, wait a minute. Yeah, much better. Okay. So I'm going to highlight this part because this explains something that I was really not understanding, and it's actually much easier than I thought that it was likely to be, right? So let's copy that. See here for information on variable binding. Okay, so yeah. So it's actually much simpler than what I was thinking originally. And quite different from what I was thinking originally. So we want maximum weight as capacity. Then we're going to do this as filtered items. Then we did filtered items toString here. All right, so now we're not going to do toString. We're going to get rid of that and try that again. Okay, so now what does it say? Unexpected if. Because we need to do a pipe, is that it? Knapsack 2 is not defined at top level. Okay, right, because we changed this. So it's going to now be an object piped into, or no, excuse me, here it's going to be different. We're going to pipe an object into here. It's going to be maximum weight capacity subtract filtered items. And items filtered items $I plus 1 slice. Okay. And then we get rid of all of that. Okay, so that's a long line too, but let's see what it says now. Unexpected semicolon. I got 96. Okay, so, so that's definitely no good. But it's okay on the first two. 96. Okay. Yeah, this reducer is overly complex. It's definitely simpler in Python, but that's probably because I just am much more familiar with Python. Okay. So we got 96. So some math is wrong. So we think we're putting in a maximum weight. We think we are taking a capacity, and we think we're subtracting this. Okay. And then we think that we are slicing the filtered items. Okay. So I don't think that using this function here is doing anything for me. I think I'm going to get rid of it. And just put this back in here. Okay, still says 96. So reduce keys. $i. So capacity here, I believe, should still be fine. It's the maximum weight we got earlier. This filtering, I thought looked like it was working correctly. It might not be, though. Okay, let's make sure I really think that that filter is working correctly. So it said weight 2, 2, 2, 2, and 10. And what's it look like in the test? This one, 2, 2, 2, 2, 10, and the max weight was 10. So interesting. So it should filter out the 10 after we take any of these 2s. I'm not sure whether I expect it to be doing that. Okay, there's the 96. And then is the 96 actually seems too high, right? 5, 10, 15, 20, 41. Any higher than 41 is crazy, right? $41 would have been taking everything. So print, is there a console? No. Is there output? Produces an output. Debug? Okay. I don't think I know how to take a peek at standard error. Okay. Ubuntu echo standard error. Okay, let's try it. I don't think I ever have really known about this because I don't think I needed it. I probably did need it and just didn't notice. But let's try this. So, no, wait a minute, wait a minute. If something has just been sent to standard error, can I see it afterwards, after the fact? Let's look at Wikipedia. I think this is something that I'm 100% supposed to know, and probably did know, and just didn't get it, or just didn't remember, or something. Okay, so I'm just gonna try putting debug here. Ah, okay, so it's actually fine. Okay, so let's look. So we got everything at first. Okay. And then we got 3 things. That doesn't seem right. We got... Oh, yes, it does, because we filtered out the heavy one. Okay, yeah. Then we got 2 things. Then we got 1 thing. Okay, I see where I went wrong. I added them all together instead of returning the max. I'd completely forgotten that it had to be the max. I had completely forgotten. See, honestly, this happens to me a lot. I'm just so bogged down in unfamiliar syntax that I forget basic things. And I have come to start to think that this is a big part of the value of working with tools that you're very familiar with. Is just that, like, if I'm working with JavaScript that I'm very familiar with, I just find that I make way, way fewer of these sort of boneheaded errors. So I've come to start to think that a lot of these boneheaded errors come from being bogged down in unfamiliar syntax. I don't know if other people think that way. I think that younger and smarter people do better with this sort of thing. I don't know if I did better with this sort of thing when I was younger, personally. Maybe not. I'm not really sure. I think many people do better with this sort of thing than I do. Maybe it doesn't have to do with age. But regardless, we have to take the max here. So we're not trying to add these together. We're trying to get a max. So instead of reducing, we're going to do something different. It might be map. It might be map. Where's map? I think it is map. So I think we want to map, except it's more like this. We're going to take this and then go map. So then we are not going to have $I. We're not going to have init. We're not going to have this. This is going to become dot. And here as well. And here as well. Okay, and then we're going to get max. So I think max is probably provided. Okay, so we'll just do max. Okay, let's see what that gets for us. I cannot iterate over number 0. So I think I can find that. So keys dot here. Cannot iterate over number 0. Oh, I think we leave this out. I think we don't need this. Okay, so it passed. Okay, so I'm gonna comment out the debug for a second then. We might need it again. Okay, let's do the next test. Actually, let me take a quick look. Do I think that this might be fully working now? I think that this might be fully working now. Let's do the rest of the tests all at once. Okay, so that is working. I'm gonna submit. And I'm gonna go ahead and mark it as complete while I'm thinking about it. So I did spend a long time on that one. It's JQ. I'm not very familiar with the syntax yet, but I mean, I think that this is, you know, valuable, like, learning experience or whatever. So let me try, I think I do still need that comment. I can get rid of the debug. Actually, I think I prefer to still have that debug. What I want to try to figure out is, can I make this super long line shorter? So for one thing, I can probably bring this down. And I could bring this down. But I have this huge long line of what is passed into map, right? So let's see. So the end of map is here. Nope, I meant to test. Oh, it's still okay. Okay, so I think that's a little bit nicer. I guess what I wonder is whether I can maybe separate some of these things out into their own functions, but it seems like that's going to be a little tricky to do. So creating this object, I think, could totally be put into its own function, which would take what? It would take the capacity and the filtered items and then this dot thing. So, yeah, let's try that and see if it works. So def new knapsack, I guess. And it takes a dollar capacity and a dollar filtered items. And then it does this. Where'd my music go? Come back! I gotta... Oh, is this one on my list? I need to take this off of the playlist. It's Dawn Ellis, Princess Leia's theme. Star Wars, which I was on the fence about including this track on the playlist anyway. But I need to add it. Songs to remove. Okay, let me write this down. Let's see where my pen is at. Oh, right here. Yeah. Dawn Ellis. Princess Leia's theme. I'd like to do some John Williams on the playlist, whether Princess Leia's theme or actually more likely something from Attack of the Clones. There are some really delightful themes, John Williams themes from Attack of the Clones. I would probably find some cover version of something from Attack of the Clones. That'd be awesome. I do think that The Phantom Menace is probably John Williams' best work. And Attack of the Clones is also pretty excellent. All right, so anyway, that's neither here nor there. So let's see if this works like that. So here, instead of doing that, we'll try putting new knapsack, capacity, semicolon, filtered items, like that. Okay, anything else? So yes, I think that's a pretty big improvement. I'm gonna do def add value. This might be going too far, but let me see how it looks. Capacity, filtered items. Oh no. Unexpected semicolon. I can probably fix that. Where's that? Where's that at? Map, add value. Darn. Unexpected semicolon does it. Line 10. I messed it up. Possibly unterminated if. Line 16. Oh my gosh. Number and object cannot be added. Oh man, I messed it up. I messed it up. So no, this add value cannot work. I was being silly. So it can't be like that. has to be filtered items dot value plus new knapsack dollar capacity dollar filtered items. I still have something mismatched. Okay, so that's okay. I just don't like seeing so many of these lines so long, to be quite honest. I usually try to keep them a little shorter. I mean, that's a pretty superficial, silly thing to be too worried about, I guess. I don't think that's necessary right there. Okay, I think I've gone too far. I'm trying to keep the line lengths a little shorter, but I think I've gone too far, honestly. I may have gone too far. I'm gonna leave it just like that. Let's see. I'm pretty happy to have done this one. I think JQ, it's the syntax is pretty different from anything that I've been familiar with. Oh, interesting. This one was listed as a hard in JQ. I don't think it's a hard. I could see possibly a medium, but I think it's, to me, kind of on the borderline between easy and medium. If not for being in JQ, it would be an easy for sure. It's a little tricky to know how to do it in JQ for me. But yeah, I wouldn't call it a hard. But either way, but it's JQ, it's unfamiliar syntax. It's pretty different from other programming languages that I have worked with, but it's not really difficult. Some things were a little tricky to wrap my mind around, but nowhere close to Prolog. Prolog has been very, very difficult for me to wrap my mind around, and this has been fine. This has been generally fine. So that's cool. So now the next thing on the agenda is to try and figure out if I can get LFE, Lisp flavored Erlang, to work. Okay, so knapsack, we still have to do it in Prolog. I don't know. I don't know. Hopefully it'll be fine. We still have to do isogram in Prolog. Still have to do zebra puzzle in Prolog. Have to do Minesweeper in Faro Smalltalk. That one annoyed me the other day. But the next two on my agenda are these two. So the only problem with these two, and I had a similar problem with ReasonML. I don't know why these three are all grouped together under anagram. I kind of had a hard time getting ReasonML to work at first, to even get the Hello World to work. And then I find the ReasonML syntax rather annoying, honestly. Let's take a look. So it's basically an OCaml-like, but it seems like they've borrowed some JavaScript-like syntax. And don't get me wrong, JavaScript is my personal favorite programming language. I love it. But I don't see any need to adopt JavaScript-like syntax into an OCaml-like language. So I don't like it nearly as well as like Elm, for instance. Anyway, enough about that. So Lisp flavored Erlang. I have not gotten the Hello World to work yet in Lisp flavored Erlang. So let's try it right now. Let's take another look. So we are going to go local and we're going to go here. So I tried using it with brew. And now let's look. So let's see what happens when I run LFE right now, because I think running LFE is fine, right? It opens this REPL, no complaints. I don't really know what to put into the REPL as of right now, but it seems okay, right? But then if I go to LFE and I go find the hello world, and I look at the help, it says, I mean, it keeps it pretty basic. To run the tests, open a terminal window and run the following from the exercise directory, make test, right? So let's see what it says when we do this. So it doesn't look good already, right? So we did make test. We're like analyzing applications. Okay, compiling zipper. All right, compiling Katana code. Sure. Uh-oh. Compiling build default plugins Katana code source Katana Dodger Erlang failed. All right. So it failed to compile something. And so we've got to troubleshoot, I guess. So I tried Googling and I don't know. So let's try Googling this message right here. And I don't know. Do you think it's going to bring up things I've tried looking at before? Okay, so they're not marked as having clicked them before. So let's try this first one. Rebar can't compile a plugin. So I was using make apparently. So let's take a look at what is in our make file. So it says Erlang shell which Erlang. So which Erl. It says it's Linux brew bin Erl. Seems okay so far. Which rebar 3. Okay, that's similarly Linux brew bin rebar 3. So that's matching up, I guess. So then what do we want to do here? Cannot find Erlang executable. Can't find rebar, but we didn't get that. We were fine. So then we tried running rebar 3 compile. So let's try that. Rebar 3 compile. Okay, so that's where we get the problem. So let's try looking in our rebar file. This is all in build, right? And we don't think any of this is going to work. Oh, that's kind of a lot, actually. Okay, okay. So I think we want to look in the rebar config file first. So we have plugins, and it's just rebar 3 LFE. So it seems like that's probably required, right? So let's look that one up. Rebar 3 LFE plugin. So maybe we'll find that there's a newer version that would be better for us. It says 0.4.10. So there is an 0.4.11. So maybe the next thing to try would be to do that. So let's change the 10 to an 11 and see if anything's any different, I guess. Should we just do that? Let's just do that. Okay, so it looks like it's the same, right? Okay. Okay, let's look in this config again. So we have provider hooks, deps, LFE, test eUnit. So what's with the katana? What's in the rebar lock file? Okay, I don't think I need to mess with that. Probably. This katana code, I think it's a dependency of maybe the eUnit. And of course, we do want to use eUnit to run the tests, I think. But we want to troubleshoot whatever it is that's not working. LFE rebar 3 plugin for the L-test framework. Now, I'm assuming that if we try some other LFE exercise from Exorcism, it's probably going to fail the same way. Let's take a look. So we're trying the Hello World, right? But what if we go to some other exercise? So it says they're all locked because we haven't knocked out the Hello World, right? Which normally is fine, but in this case is maybe a little annoying. Because the Hello World's not passing, and we're trying to troubleshoot it, right? And I say it's not passing, but it's actually just not compiling, right? Def module, hello world tests, ltest unit export all. It does look Lisp flavored, doesn't it? That's neat. I don't think I'm learning anything from that. What about source? So what's the app source file? Erlang application hello world. Okay. Okay, let's try again. So we've got to be careful when Googling, I think. So the problem is specifically with Katana code, right? So let's just Google that part. Because unfortunately, if you give Google too much information, it gives you less targeted results, it seems like. Or well, you just have to be careful. Okay, so Katana code utilities for Erlang. So let's look at issues. Okay, this looks like what we have been seeing. So does somebody have a comment? It says it's a bug. This person is looking at the exact same file, I believe, that I was looking at. But he's not saying that it fails to compile, I don't think. Okay, he's looking at Katana Dodger, and that's something that I'm seeing here. But this just says syntax error before else. I think that this is something different from what this guy's looking at, right? So what is the deal here? Okay, so it looks like we need to go fix this file, probably. So let's go into build, and it is in default plugins, Katana code, source, Dodger, Erlang. Okay, so now we're gonna try to find where it said else. It was this one, right? Quick scan form. And it ended up saying that there was a syntax error before else, right? So can we possibly spot what that might have been? Well, it looks the same as what went before, so what's happening here? See, it's syntax highlighted differently. These elif, ifdef, ifndef, these are syntax highlighted as spelling errors right now. Which, honestly, I should probably turn off the spelling error highlighter. Should I do that right now? Maybe. And then here as well, scan form. So these were the two that were marked as errors, right? Uh-oh, look. This one is this one is quoted, single quoted. And this one is not. And this one is not. Does it matter if they are single quoted? Let's try adding single quotes on it. I don't know. I think an atom, whether single quoted or not, should be the same thing. Huh. Interesting. So I'm surprised that I had to make that edit. I wonder if anybody in here was talking about that. Huh. So, I mean, interesting. I'm gonna call that out on the Discord. Maybe. Maybe. Let's see if other people are talking about it. I'm talking about the exorcism Discord, right? So let's just see. LFE. So this is why is there no HTML5 course? Hey everyone. Oh, look at this guy. Latest numbers. This was from a while ago, March 6th. But that's cool. I was wondering about that as well. And look, they got badges for a bunch of languages. COBOL should stop accepting new students right now, says Veying. How many does it have on here? Two, 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 two. Oh, is that like an angel number or something? Okay, very fun. But anyway, it doesn't seem like somebody's talking about it. Oh, wait. Is this somebody talking about it? This is exorcism. Interesting. So if, yeah, I'm surprised that I had to make that edit. I guess that's it. But I don't think I'm going to do anything about it right now. I think I'm just going to go ahead and move on. So let's edit our file. And let's submit, and I'm going to take a 5-minute break here. So this is actually good progress, though. Oh, it's source hello world, my bad. There it is. Okay. Okay. This is good progress, I think. It gives me hope that I might be able to do the COBOL one later as well. So I'm going to mark that as complete. So now it will let me presumably go to the one I need to do. Okay, so it looks like I've done it 5 times already. So LFE very much looks like a Lisp. So if I were to choose a Lisp to do it in, I would say that my favorite of the Lisps is probably Clojure. So do I want to do it in Clojure first before trying it in LFE, or do I just want to bang it out in LFE? Probably just bang it out in LFE. And let's see, are any marked started but not completed? Doesn't look like it. Okay, so let's just do LFE. So I'm gonna run test. And it says compiling failed. Warning, warning. Let's see. Okay, so I think it's fine. I just need to go ahead and define my file. So do we defun find? Kind of a noisy output. All right, so bad clause form. So let's look at the anagram tests. So they did def test. Okay, so we're gonna find the LFE docs. LFE define function. So this is LFE Gitbook. Okay, so defun, that part was right. But it looks like the name, and I think this is actually just me forgetting how it actually is in Lisps. So it should be name. I think it's maybe more like that. Symbol high is unbound. Darn. Okay, I gotta take my 5-minute break here. Okay, cool. So it compiles now. All right, 5 minutes, and will be back. Okay, okay, I'm back. So, oh gosh. Um, that might have been more than 5 minutes. All right, so let's finish up this LFE. Oh no, oh no, had my music stopped? Oh, I think it's just between tracks. Okay, LFE. 16 tests, 16 failures. Okay, so we were supposed to filter on whichever ones are anagrams, right? So basically, to do anagrams, I want to count the characters and then just see if the character counts are the same. There are other ways, probably, to do these things. So, like, here the question is, like, filtering anagrams. If we wanted to find anagrams, we could probably use, like, a tree, like a prefix tree. If we wanted to, like, find all the anagrams in a dictionary, it would be better to use a prefix tree, but here they're just passing in a list of words. And the lists of words are pretty short, so it's not really necessary to use a prefix tree. It still might be a good idea. Like, it would be a better way to solve the problem because then you could handle large dictionaries very efficiently. But yeah, so they're just pretty short lists of words, and some of them are anagrams and some of them aren't, right? So anyway, if we have allergy, we should say gallery, yes. We should say ballerina, no. We should say regally, yes. We should say clergy, no. We should say largely, yes. We should say leading, no, right? So pretty straightforward. So in LFE, can we, how are we going to do a count? Okay, so the exercise is anagram. And I don't think I've done it in anything that was like a Lisp type thing. And I don't think I've done it in anything that was an Erlang type thing. I did it in ReasonML, that was asked for. I did it in Python. I did it in JavaScript. I did it in F#, and I did it in C#. So I feel like doing it in Gleam. Yeah, like basically the thing here is I just have no idea really how to do it in Lisp flavored Erlang. If we look at the Python solution, for example, this one's actually quite short because we used this data structure that Python provides, the counter, and that does basically most of the work. A counter like this is simple enough to implement, though. If we look at the JavaScript version here, here's what we've got. Looks like I left that in there. So here we have a function to return a count. And I mean, there's not a lot to it, right? We're gonna need an object. And then we are gonna say A for each E. And then we're just gonna say if it's there, then we'll increment. If it's not, we'll initialize at 1. So then when we do the letter counts, we just spread that into an array and get the counts. And then to see if it is an anagram, we're going to take these two comparisons. We're going to do them both to lowercase, because that's part of the problem, is that we're supposed to count upper and lowercase as equivalent. That's fine, that's normal. So if it's the same thing, then we're going to say false, because that's not an anagram. It's not an anagram of itself. Then we're going to count. Oh, interesting. So I'm a little surprised here. I think it's fine though. So we just counted the target, and then we went through the other string and decremented the count for every character that we saw. So if it's not in target counts, or if it's less than 1, return false. Interesting. So that's probably better than counting both, because then we don't necessarily have to go through the entire string of str. We do have to go through the whole string of the target in order to count them all, but we don't necessarily have to go through the whole thing of str, because we'll return false as soon as we find that it's not an anagram. But then, yeah, so then if we don't, like if letters are missing in string that were in target, then we still have to be like, okay, let's make sure they're all 0. And then we just filter like that. So, in short, my thought for Lisp-flavored Erlang is that we probably want to do all these same exact steps, I guess. But I don't know. I don't know how to do any of them in Lisp-flavored Erlang. So, I guess we would start with the count, right? So that for the count, we're supposed to create some kind of dictionary or associative array or whatever it's going to be called. But it's going to be characters with the number of times that each one appears. So let's look at dictionary, hash map, Lisp flavored Erlang. Property lists and hashes. Okay, so Lisp flavored Erlang. Property lists are just lists whose entries are key value tuples. Alternatively, an entry may be a single atom, in which case it implies a tuple with the atom as the key and true as the value. So it's just a regular list. Okay, fair enough. Let's see what keys we have to find. Okay, so we said set plist. This is docs lfeio. This looks pretty nice. In fact, this by itself, I think, is pretty much going to tell me what I need to see. Property lists, key value tuples. There's no built-in dictionary or hash type in Erlang. However, there are some libraries that support data structures like these. There is also a concept of records, which we will discuss in another section. The Erlang dict module implements a key value dictionary part of which is an additional dict data type, which supplements the built-in Erlang data types. Here's how you create a new dict. Oh, so maybe this is what we need to do. So we said dict new. Then we said dict append to C moons of Jaglin beta. Okay, okay. Dicts are not updated in place. A new dictionary is returned with each call to append. Okay. Dict fetch to avoid my dict. Why the is the function called append accepts multiple values for keys. So they appended here. Did they append again? Oh, shoot. Okay, okay. Set, ordered set, bag, duplicate bag. All right. So I'm gonna try to do this thing. Let's go and give it a shot. Okay, so I'm going to say be fun count. All right, so count takes a list, which I'm going to call A. And then we're going to say set result dict new. Let's take a look. So I'm going to say set result dict new. Okay. All right. So now let's look at looping. So this is user guide. So in Lisp type languages, we often have looping, but not necessarily, right? So in this case, we may not have looping. Let's look at comprehensions real quick. So I don't think that's quite it. I think we just want to do it recursively, probably. And do we have car and cutter? We do. Okay, great. So set E car A. We need an if, right? I'm just going to try an if. So I'm going to say if A equals nothing, then dict new else let's look at dict again. Oh shoot, where is it? We're going to dict append car A. No. We are gonna do set result count cutter A. And then we are going to say set E car A. And then we are going to say if, all right, so now can we check membership? Query or something? So they did fetch. So fetch didn't modify it or anything, did it? Okay, let's try some of these out at the REPL real quick. So if we go LFE, actually, let me cat my source file real quick. Okay. So if we go into LFE, let's say set result dict new. Okay, sure. And then we are going to say set a list do we need to do string to list? We are going to need to, right? So if it is just a list of integers, then we're fine. We don't have to worry about whether it's a list, right? Set A, hello. Okay, so now set E, car A. So I got a number. And then we're going to say if, or let's just say dict fetch. Let's look at that. What was that? Fetch. Bad argument. Okay, so if we say set result dict append, and then when we append, we are going to put the key and the value in the dict. So we're going to say E1 result. So that says it's okay. Dict fetch E result. So now it's no error. So I don't really want an exception error. I want to check for membership. If we have to handle an exception error, I guess that's the way it has to be. But do we have another option? dict docs. Here we go. Okay, so fetch erase find. I think we just want find, right? So if we use find, we'll get OK value or error. Okay, so now if we say set a cutter A, and then if we say set, did I just put on caps lock? Set e car A. Okay, so we got a number. So now we go dict fetch e result. It says no way. So now we try dict find e result, and it says error. So that's better, right? Okay. So let's close that for a second and see if we can apply what we've learned, because if we can't, then we haven't really learned it, right? So we said if this is empty, then we're going to return dict new. Otherwise, okay, so that shouldn't be closed there. That should go all the way down. Hold on. Okay, so this if is for, shoot. So fetch, we got error back, right? Okay. So we'll say if dict find e result equals error. So that should not be the end of the if. Okay, yeah, let's do it like that. All right. So if A is empty, then we do this. Otherwise, it's going to be all of this. Let's indent everything. Yeah, that's better. Okay, so then, yeah, that goes here. All right, so then if where does that close out? Okay. So then all this down here is now nonsense. All right. If empty, then we'll return dict new. Set result to count of cutter A. Set E to car of A. If it's an error here, then we'll do dict append E1 result. So we could do set K dict find E result. And then here we would go K equals error. And then when we fetch, or no, when we find, it should be OK value. Okay. So that's not actually that useful, is it? Because I don't know how to use it here. Okay, well, you know what? I'll just leave it alone. I think that's my definition for count. So now let's go to the REPL and see if it works. So I'm gonna try pasting this. Let's see what we have. Let's see what happens. Was I missing a brace? It would seem that way, huh? Okay. All right, so now let's try it. So count. So count hello. Symbol count is unbound. All right, we want to go count hello. Function A to undefined. All right, so let's look at A. So it was count, defun count A. I think defun, I used it wrong there, didn't I? Oh, it's right here. Wait a minute. If... Oh. Oh, it's, equals. Like this, yes. I'd forgotten. Just straight up. Okay, so let's try again. Symbol count. Oh, yeah. What am I doing? Function equals to undefined. Is it double equals? Let me just try double equals. Oh, maybe it's EQ. Let me try EQ first. Okay, let's look at LFE equality operators. Okay. Is this the right place? Okay, so we want double equals. Okay. Exception error, bad application form. Darn. Bad application form. Okay, let's go through it piece by piece. Set a hello equals a false. So now let's say set result dict new. Let's try something else though. So set a cutter a. So it should be LO, then do it again. LLO, then just low, then just O, and now empty, right? And so now if we say equals A, we get true. So that part seems good. All right, so now we're going to say set result dict new. Okay. Set E. So now I'm going to set A to just O, because like as if we're at the end basically. Oh shoot. Set a, at least I know what that is, bad application form. Bad application form. So do I have bad application form here somewhere? Is this bad application form? Def count A? I think it is. That's gotta be bad application form, huh? Shoot. I don't know, maybe. I don't think it is. I think that was supposed to be parenthesized. Well, let's see. Let's see. No function clause. Okay, so we are supposed to have parentheses here. Okay, so is there another place where we think that we would have gotten that? Okay, I can't tell yet. Let's keep going. Okay, so set A, O, set result set result dict new set e car a. Why do I have find there? Or excuse me, why do I have that misspelled? I'm just seeing it now. Oh my gosh. If I just read. Okay. So it still says bad application form, so we're going to keep going. Set A, O. Equals, or excuse me, equals A this, false. Set result, dict new. Equals, by the way, cutter A. So we should be fine there. Set E, car A. Set K. Dict find E result. Oh my gosh. Again. I didn't read that even after knowing I hadn't read it. Okay, still says the same thing. I'm just gonna do it again. Set A, oh, okay. Set result, dict new. Set E car A. Set K, dict find E result. Equals K error. Equals K error. Okay, let's go change that. Now that I did not actually realize. Maybe I should have, but I didn't. Okay. Maybe I should have known that that would be the syntax. I think I was thinking just error would be more like what I expect from like the Erlang syntax. But most of this syntax seems much more Lisp than Erlang to me. So let's try count again. Bad application form. All right. Set A, O. Set result, dict new. Oh, by the way, can we do count cutter A? That should be fine, right? I would think. Yeah, we got dict new if we did that, so that's good. Okay, so now let's set E car A, set K, dict find E result, equals K error. So it did, so we're going to say dict append E1 result. Well, that does look right to me. So now, at this point, we should expect this to get returned. So if I do count A, it says bad application form. So where is it? Where's bad application form happening? Okay, can we just copy this part? What do we think is going to happen here? No function clause matching. Lisp flavored Erlang if statement, if statement. Let's see. Okay, so this is LFE Gitbook. And now can we search in here? Oh, let's see. Subst if. Predefined LFE functions. If. Oh, man. Looks like the if is different from what I'm expecting. So it says if is then supposed to apparently have G expression, G expression, G expression. But I think that's actually the same, because this is the condition, this is the then, and this is the else, I believe. No function clause matching. Okay, so let me try rewriting it. If equals k error, then we think we're going to have two of these things, and then we think we're going to close it, right? So here it's going to be dict append e1 result, and here it's going to be dict append e. Uh-oh. Oh my gosh, I'm finding problems everywhere. Okay, let's try it again. Maybe we're getting closer. I'm not sure I believe that that was the problem before, but let's see. Oh gosh, no, 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 no. Bad application form. Okay. So, set a o set result dict new set e car a set k dict find e result equals k error dict append e1 result. So far, so good, it would seem. Okay, so let's put this in if equals k, error, dict append e1 result. My posture is so bad. Dict append e plus 1, dict fetch e result. Okay. So now can we maybe do the whole thing? So if equals a this, dict new, set result, dict new. Wait a minute. Oh no, I think I have to mark it as recursive. LFE function recursive. I'd forgotten that until now. A lot of times we have to, like, say rec or something to mark something as recursive. Defun add. Oh no, wait a minute, wait a minute. So this add looks like it's fine, right? Okay. How bad does my hair look? Really bad? Yeah. All right, so it doesn't really seem like um wait a minute. What is predecessor? Okay, predecessor. Okay. So it doesn't look like we're having to do anything special to make it recursive, does it? Let me just keep going then. So then this next part is going to be here, right? Set result, set e car a, set k, dict find e result, and then if equals k error, dict append e1 result, dict append e plus 1, dict fetch e result, close if, close Uh-oh. Yeah. Okay, so now it says bad application form. Interesting. So I'm not sure I've quite narrowed it down. I was hoping I would find it in a smaller area. Okay, so what if when we append, what about here? What if we just turn this back into a 1? Let's just say it's a 1 here as well. Bad application form, so it's not there. What if here, what if we just set k here to 1? Bad application form, so it's not there. What if here we just set e to 1? Application form. What if here we just put 1? Non-Boolean if test. Oh, darn. We have like primitive data types. Bad application form. Okay. Um, okay, so what if we got rid of some of those set calls? I mean, I don't necessarily want to. But if it's bad application form, then then I don't know what we're gonna do. Variables. Variables in Lisp-flavored Erlang don't have the same syntactical limitations that vanilla Erlang has. Let's take a look at some examples in the REPL. So what is let? Let is different from set. Okay, let's see if I can understand this. So they've done let x2 y3 list xy times xy, 2, 3, 6. Set two variables. Okay. In that case, maybe we want to try let. So was let... Okay, so the thing is, let was not even closed. Okay, okay. So maybe this is what we need to do. Let, and then get rid of set. Maybe that makes more sense. Let's see what the REPL says now. Bad let form. Okay, let's look at it again. Let x2, y3. Okay, let's look at it again. So let is that better? This track has rather grown on me. What's this one called? Rodriguez Escape? Okay, okay. Right on. Symbol E is unbound. And we know, okay, so we were hoping to be able to use it because we did let here. And then we tried to use it in these few places, but no luck, apparently. Hmm. Okay, so I do need let star. I didn't see that at first, but clearly we do. So let's see what this does for us. Error, undefined function in dict fetch. Okay, let's take a look. Okay, so it was supposed to be fetch key dict, and... Oh, I didn't put the dict in there. My goodness gracious. I've been really bogged down everywhere, huh? Okay, let's take a look. Error in arithmetic expression. So it said +1, 1. The 1 was apparently parenthesized, and can we see why that would be? Error in arithmetic expression, +1, and then this one is in parentheses. So we don't want it in parentheses, I don't think. Or wait a minute. Error in arithmetic expression. Yeah. One here. Let's see the dict fetch again. Okay, I think this part we should be able to figure out. So let's say set result dict new, set result dict append 1 and then let's say dict fetch 1 result. Okay, so it came out looking like this. So do we have to put car on it? Is that it? Okay, let's do that. That's not going to work. It warned me about the append thing, and I didn't pay attention to the warning until now. When we append, it's going to add it as an extra key. We need to replace, or excuse me, it's going to add it as an extra value. We need to replace the old value that was in there. So we might need to erase. Do we need to merge, maybe? No. Append, erase, fetch, filter, find, fold. From list. Take, oh, update. That would make more sense. Update a value in a dictionary by calling fun on the value to get a new value. So here we put in key, we put in fun, and we put in dict1. So it's a fun that should take 2 values. Defun count update. No, it just takes the 1 value, right? Oh man. So it's really just increment, right? So we'll update with the key, increment, and result. So that's better. So that should be all we need to do then, I think. Let's see what it says. Increment is unbound. Let's see. Do we need a lambda? They were talking about lambdas over here, right? Is there something about, so this part it says is stubbed. Listen simple data in progress. Uh-oh. Okay, so symbol increment is unbound. So we could even update with an initial, I guess, if we wanted. Okay, let's try making this work. So we're going to say set result dict new. So now we're going to try dict update. One. Now, do we think that this might be lambda? Let's see. Lisp lambda function? Okay. Special operator function. Is that what we need? That's probably what we need, right? Maybe, maybe. Okay, so then over here it said that we should put the initial in. Where was it saying that? Here, right? Function undefined. Okay, so that's no good. What about this? That's no good. I think we need to look in the Git book, maybe? Uh-oh, unauthorized. How can this be? What happened? Why would it be like this? I don't know about Git books. Oh no, oh no, oh no. Okay, so this is where I was. User guide. Classic docs. Okay. So lambda, oh, you know, it says function here. Function, func name, arity. Oh, okay, so function increment 1. Ah, okay. So now if we say set result like this, we can do it again. That's what we need to do. Okay, so we need to use, so we have to remember that the arity is required, which is all the Erlang type languages are big on that, right? Okay, so we don't need to do if at all. We are instead going to do, and in fact, we don't need this k at all either. And I believe I think we only need the e once, right? So this is going to be greatly simplified. Yeah. I think we do need the result, right? Or do we? We may not even need that. I don't think we even need that. So this is going to be much, much, much simpler than before. I believe that all we need here is to go dict update and then char a and then function increment 1 and then the initial value, right? 1 and then the recursive call count cutter a. And I believe that's it. Oh, I love it. I love it. If it works. But man, I've been sitting here trying to figure out what to do. But that's actually really nice. Okay, let's give it a shot here. That hesitation is making me think, oh, deep down inside, do I not think it's going to work? It may need more troubleshooting. Let's see. Okay, so yes, there are the counts. Let's try counting something else. Fabulous. Fabulous. It works and it's much, much simpler. Amazing. Amazing. So, yeah. That's really, really nice, in my opinion. So, cool. Okay, let me do it like that. All right. So that's the count. That's the first step. Unfortunately, the other steps I think are going to be just as tricky for me to try to figure out. So here it was in JavaScript. So to get letter counts, okay, we don't need to worry about that. So that's something that's simplified. Okay, so then is anagram. We want to do lowercase, so we're going to look in Erlang to look for something about lowercase. Let's see. Erlang string lowercase. Do we have something? I think we have something. Okay, case fold. Converts string to a case-agnostic comparable string. Okay, so we're going to try to use that. Let's go into LFE, and we're going to go... Or we're going to go equals hello, hello. Can we do that? True. Now if I capitalize, it says false. Okay, so now if we try case fold on both, case fold, so then it's undefined, but I think we can get it if we go string the way we did with dict. Have I found something that works? Okay, so that's what we're going to do for the comparison. Okay, so I am going to close a whole bunch of these. Everything to the left of there. Any Google tab is getting closed. And then, is this one useful? Perhaps, 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 maybe, perhaps. Not this one, that's new tab. I think I'm done here. And I think I'm done here. Okay. Cool. So we'll use colon string case fold. Love it. Okay, let's start. So I'm gonna go let star, and I'm gonna say let's say this is gonna be string target, maybe. I'm gonna say okay, so there is one. And then this next one is going to be lower target, case fold target. Okay. So let's put these variable definitions on their own line, I guess. Okay, so after we've defined some things, we're going to go if equals lower string, lower target. So if they are equal, then we're going to say, oh no, this is supposed to be is anagram. Okay, so in this case, we will come back and say false, right? let so this one actually doesn't need the star. I'll get rid of the star if it's not needed. This music is a delight. Okay, so yeah, letter count, slower target. Okay, so then it looks like we iterated through there, right? And we're decrementing the count. So this will be countdown. So countdown is going to take counts and A, I guess. So we're gonna do dict update. No. First of all, we're gonna say if equals A here. Then we give counts back at that point. No parentheses. There we go. Otherwise, we will dict update char A function decrement 1. There's an initial. So I guess the initial in this case, I guess should be -1. And then here we are passing in counts. Or no, actually, countdown. This one should be, okay, so counts is a dict and A, okay, so this should be countdown cutter A, like before. No, that's not right. Oh, yes, it is, because it gives back the dictionary. Okay, so it is right, I think. Okay, let me think through it again. So if it's empty, then we just give counts back. Fair enough. Otherwise, we are going to give back an updated dict. Okay. And that updated dict is going to take char A as the key. That part makes sense. It's going to take a decrement function as the update function, so that also makes sense. The initial value will be a -1, sure. And then we're going to pass in as the starting dictionary whatever comes out of countdown, passing cutter A. So yeah, that does seem straightforward enough. So then here we definitely do need let star because we're going to say um, counted down will be count down, and passed in there will be target counts and lower string, right? Okay. So that'll get us to this point, and now we have to make sure that it's all zeros. So on dict, we were able to go get like all the keys, right? Or excuse me, all the values. I think both, but all the values are the ones that I want. Or not. Fetch keys from list is key. So do we need to list? I guess probably. Or do we need filter? Do we need fold? Ah, this would perhaps make the most sense. So fold. I don't think that does make the most sense. I think, wait, what about map? No. I guess it doesn't matter. Fold is probably the most straightforward. So we'll pass a function, an initial, and the dict. And so then the fun takes key value ack in and gives ack out. Okay. So here we are going to do dict fold. And then I guess we want to define the function here. So function fold counts or values are 0. And it takes a key value ack in, so I'm going to put 3 for the arity. And then the initial is going to be true. No, that's not it. Boolean operators and or. Okay, yeah, we should be able to do that. Let me just check it at the REPL. So uh-oh, that's not right. What the heck? So what even is the and? True and false? And I got true? Why? What happened here? It said Boolean operators and or and negation operators not thing. Oh wait, it has to be, oh wait. It has to be and true, false. Huh. Okay. Yeah. Okay, gotcha. I think. Okay, so the initial will be true. And then what else do we do in the fold? then we just put in the dict, and the dict is going to be counted down. Okay, and that should be the whole is anagram. Okay, so now we'll go ahead and define efun values are 0, which takes key, value, and ACK. Okay. And this one will give back and ACK equals B0. That's it. Okay. Okay, so that brings us to the end. So here we should filter. So we're looking at dict, but list should be in here somewhere as well, I believe. Lists. And we should have filter. Which takes a predicate and a list one. Okay, so let me just try copying everything that I've got so far down to here. Okay, so let's say is anagram gallery allergy casefold undefined. Yeah, I messed that up. I don't that was a brain fart, 100%. Okay, is that better? Bad application form. All right, so now now that I've been working with this a while, do I know what bad application form likely means here? So this false here, that's wrong. Let's fix that. This has to be like that for sure. So that was one clear problem. Let's see if it changes anything. No, it still says bad application form, so let's see, we caught one here. Let's look at values are 0. It's supposed to be key value ACK. And it was supposed to be dict fold. So I don't know about that. What about countdown? You think countdown will be okay? First of all, let's go count allergy. So there we are. And now let's count down. Count allergy. Gallery. Countdown. How did I mess that up? Countdown. Count allergy. Gallery. I thought I passed 2 in. What's the deal here? Countdown counts A. Oh, I only passed cutter there. So here we needed to pass counts, right? Counts 1. That should be clearly spottable. Here's counts. Here's counts. Here's counts. So this one is just count. Okay, so there I see the zeros. That does look okay. Now what about is anagram allergy gallery? Yeah, bad application form. This doesn't look right. What's going on there? Let's go fix that. It's making me look at this stuff with a critical eye. And this is one of those areas, like being unfamiliar with this syntax, I would like to have an LSP working better for me. It's a crutch, of course, but at times like these, I love to have that crutch. Okay, so allergy, gallery. Okay, it says true. Now, what if it's the same word? False. Okay, that's better. Now, what if it's just an A? False. And then what would be another one? Real glee. Sorry. Okay. Sure, that's fine. And if we get rid of a letter, it's gone. And if we put too many, I think that part is working. So then here, we're supposed to do the actual filter. Okay, so cat one more time, back into here. So I'm gonna try and go list filter, and then the filter is supposed to take a predicate, so that will be function is anagram arity 2, and then we're supposed to pass the list itself. So is anagram is not going to work there. The predicate is only supposed to take the one element. So let's go back and fix that. So defun anagram filter, which takes just target. And then here, we just return what do we return there? We return a function. Shoot. We return a function that just takes str. Okay, let me see here. Lisp higher order function. It seems like we're probably supposed to use the function keyword again, but the way I've been using it is just to say, oh, hey, I have this function with this name and this arity. So let's see. Apply. Apply gets passed the function value of append. Map car gets passed the variable value of function. Is this what I'm going to want to do? Or, well, I don't know. I'm going to crack open another can. It seems like this might well be what I want to do. Hash is syntactic sugar for function. So I think I really need to know more about the function keyword. Where was I looking at that before? Here, right? So we probably want a lambda expression like this, I guess. Let's see what I think that'll look like. So we'll put function, and then lambda, and then it takes str, and returns is anagram str target. So, I mean, it seems straightforward enough, but is that how we actually do it? All right, we'll find out. So, let's cat that and go here. And copy paste everything. Okay. So, I want to go anagram filter gallery. And what do we get? Function 1 undefined. Okay, so I can put the arity in there. That should be fine. So we're putting in a lambda. So after the lambda, we have to say, oh, by the way, it has arity 1, right? Okay, let's try that. Okay. So let's go anagram filter gallery. So now we do have a function. All right. Now, can I call that like this? No, bad application form. But let's try and call it in a filter. So I'm going to say list filter, and for the predicate, I'm going to put anagram filter gallery. All right. And then I'm going to put in a list of allergy and lallergy, and dog. Undefined function. So that part should be okay. Is filter the one that's an undefined function? It looks like it may be, yeah. Now, I would say we should probably be able to just filter like that. No, function filter to undefined. Okay, so let's go to LFE list filter. Let's see if there's some information. Lists and simple data. So here is an example. So here we did lists colon filter, and then we did this predicate. Okay, let's try that. Lists colon filter, anagram filter gallery, list allergy, lallergy, dog. Bad application form. Okay. So where it's bad application form, do we need to put function here as well? No. Lists filter. Lambda expressions in function position in a function form. So that's supported for Common Lisp. Lambda foo foot. Well, let's see what if lambda foo 10. No, that's bad application form. So that's not supported here. So we want LFE lambda. Oh my gosh. LFE Lisp flavored early lambda. Lambda functions and higher order functions. Give me the deets, baby. Is it this? Maybe. Okay, so function reference, function funcname arity. Let's keep going. Inside functions, optional comment strings in common Lisp style. Okay, convenient. Optional comments are also allowed in match style functions. Ah, okay. flet and flet rec. Function binding and scoping. Is this going to help me? I think I just need to keep looking. Export all functions. Macro calls. Records. Predefined. I think I've missed it. I think somewhere that I saw it must have told me what we're doing and I just didn't get it. Probably. Okay. So function reference. Lisp using function reference. Okay, hold on. So what if we do function lambda foo arity 1. Okay, so now can we possibly just put something in there? No, bad application form. I don't like seeing bad application form. I don't. I'm getting close to the 4-hour mark, my goodness. I do not like to see bad application form. So we can't do that. So what can we do? What can we do? So that gives us a hash fun. And now, can I pass something into here? Not the way I tried to before, but there must be some way, right? I hope there's some way, otherwise I'm going to be pretty confused. So I don't think it's here. I think, maybe Wikipedia has something to help us. Maybe. LFE has lambda, just like Common Lisp. It also, however, has lambda match to account for Erlang's pattern matching abilities in anonymous function calls. Okay, well, I don't need pattern matching. I just need to make a regular anonymous function call. Okay, so we used compose here. Okay, so this hash apostrophe, this is gonna, I think we need to use this, right? So we did compose, and we put two functions together, and we assigned it, and then did we use it? Sorry. Oh, we used fun call. Fun call. Okay, let's look that up. Fun call. LFE. Okay. We need fun call. I don't know where that was in here somewhere. Was it in here? I just didn't know that that was the term for what we needed. Yeah, here it is. Fun call. Okay. Okay, let's try it with fun call. So we want fun call, and then we'll put 10. And now are we okay? No, bad application form. So let me look again. Fun call. Shoot. So in LFE, we fun call on func. Shoot. I don't get that part. So lambda x, we fun call f. So we did let, and we gave a lambda back here. Okay, yeah, I'm so dumb. I do not get. So I tried to do fun call. I tried to put in a function. Oh, maybe we don't want a function. Maybe we just want the lambda itself. Wait, what is the one? Oh, the one was supposed to be the arity. But what if we just do that? Okay, so we can fun call that. Okay, okay. All right, so this seems much closer, I think. Okay, so now if we do this again, we are going to do anagram filter allergy. And now I'm going to do fun call on this. And what does that give me? Okay, cool. So now can I give it gallery? No, bad application form. Interpreted function with arity 1 called with no arguments. So I think I may need to just rewrite this. So I have it return function, but I think it needs to actually just be the lambda itself, right? Because that's what I saw in the other place. Okay, let's give it a shot. Okay, so we're going to go anagram filter gallery. So I got fun. Okay, now can I fun call? Okay, and now can I put something in? Ah, indeed. Okay. So we need fun call. All right, it took me a while to find that. Honestly, I can't think exactly. What ended up working for me was looking at the Wikipedia page, right? So let's keep that in mind for future reference. Looking at the Wikipedia page is rarely a waste of time. I mean, it's weird to say it that way because looking at a lot of Wikipedia pages is a common and well-known time waster. But if you're trying to learn about a particular topic, looking at the Wikipedia page for that topic is rarely a waste of time, in my opinion. Because, like, this article I think is excellent, and most articles on computer programming topics on Wikipedia, in my opinion, are pretty excellent. So, anyway, let's finish up now. So we're gonna go lists filter. All right, we're gonna put the predicate in, which is going to be just anagram filter. Yeah, I still don't know. So is lists filter itself going to fun call? Okay, so that's what I'm gonna put in there. Let's cat again. Let's copy everything. Okay, here we go. So I'm gonna try lists filter, anagram filter, gallery, list of gallery, allergy, lallergy, dog, nothing. Okay, amazing, amazing. All right, so now we're gonna try find. So we're gonna go find gallery, gallery, allergy, lallergy, dog, nothing. Oh, bad application form? Really? Really? Oh, I put a parenthesis where it didn't belong. Ah, there we go. Okay, okay. So let's run the test now. Man, that's been wild. Okay, so we ran 16 tests without failures. A bunch of warnings popped out, but... Oh, look, right here. Katana Dodger. Is this still messed up? Okay, I think it's okay. So let's just submit. And I'm about done for the night, actually. Man, okay, so we're gonna submit source anagram LFE. You know what? I haven't decided that I really want to be finished for tonight. I'm gonna take a 5-minute break and think about whether I want to be finished for tonight. Let's look at this and see if we can mark it as complete. This one's an easy. Compared to JQ Knapsack, I did not find this very easy, but the thing is, a lot of people probably know Lisps pretty well. I just don't. So, I think a lot of people do know Lisps pretty well, from what I understand. All right, but I don't. I'm learning through doing this challenge. I'm learning a bit about the various Lisps, and I think I'm getting better. But I made a lot of boneheaded mistakes that I wouldn't have made if I knew Lisps. Okay. So now, let's see how many I have completed. 137. Right? So there are 7 left. And how many days left in the year? So here's today. 1, 2, 3, 4, 5, 6, 7. Okay. So I'm down to 1 left per day. I have 7 assignments left and 7 days left in the year. So the next one on my list is COBOL. And there's no way I'm not going to do that one tonight. In fact, to be honest, I don't want to do COBOL tomorrow either. What I want to do tomorrow, and hopefully I'll get up in time and not be a bum. I was a bum today. I should have spent more time today. But, you know, I got a couple things knocked out. What I'd like to do tomorrow is focus on some prologue stuff. So if I'm looking at the prologue stuff again, I have finished the Hello World plus 3 basic exercises. And on Code Wars, am I still logged into Code Wars? Yeah. So in Code Wars, let's take a look. We're going to go by most completed. We're going to go by just prologue. Approved and beta, that's both fine. Okay, so this shows that I knocked out prologue multiply, and prologue even or odd, and prologue multiples of 3 or 5, but not prologue vowel count, right? So I think tomorrow what I would like to do, I think I'm just going to focus on a few problems from Code Wars and Exorcism. And if I can finish just about like 6 more problems in prologue, I think I'll understand it a lot better. Let me just take a quick moment to review the ones that I actually did. So here's one. And here's my past solution. So multiply, we take in an x, a y, and a z, and then we say it's going to match if z is x times y. So we use the arithmetic there. Z is x times y. All right. So, I mean, obviously this is a very simple one. It sort of illustrates kind of the way prologue syntax is, to be honest, and I shouldn't let it bother me. It's just a programming language like any other, right? I don't know if that's true. It's certainly harder for me than most others. Okay, so then here for even or odd, we take in a num and a string even, and we say, okay, so this one is true conditionally if num mod 2 arithmetic equals 0. This one drove me absolutely crazy. It took me forever to find the equality operator to actually use. And I keep calling it arithmetic equals, and I don't even think that's what it is. But trying to Google it has not been all that successful. Let's see. So did I look at this before? So this is arithmetic expressions. Let me take a quick look at multiples of 3 or 5. So for this one, let's see what I did. Okay, so I used quite a bit of code here, kind of a surprising amount. So I have one function, addend, apparently, where I have NA, and I'm like, okay, so 0 is mod N3, and then I used this arrow, and I said A equals N, so this is another equality operator, and then is another equality operator. So we said 0 is mod N5, AN, and then here's A0. So basically, whatever number we put in, A is going to come out either as N in these two cases, and this semicolon is used for the OR. But if neither of these two cases is true, then the remaining case is that A will come out as 0. So then we say, all right, so the solution will come out as 0 in the case where number is less than 3, fair enough. And then we have this beast, which honestly I find rather convoluted. And I don't know if I looked at other people's solutions for this one yet. I'm not going to right now. I'll look in the morning. Number result. So we said decremented is number -1. And these had to be done in order, so we had to be careful about that. Then addend, decremented addend. So addend is assuming that we know what n is, right? If we don't know what n is, then we can't figure out which of these to match. So decrement, we have to figure decremented out before we do this. And then solution, decremented recursive result, right? So a recursive result is coming out. And I believe that's generally the convention, is that we put things that we need to know what they are first and things that we're going to calculate after. And then finally we say result is, and we do addend plus recursive result. So yeah, I mean, it makes sense. It does seem a little weird though. Let me quickly review these other ones as well. So wedding woes is quite simple. And it's nice. It's kind of introducing some of Prolog's strengths, in my opinion, because we can define these facts. So Gustavo and Valeria, and so these names are all kind of like atoms, similar to in Erlang, from what I understand. So that's cool. And then, so then these are facts. So it's just likes Esteban Malena, right? So there's no conditional here. So then we do these conditional rules. So if we have A and B, then if this is a fact and the comma is for and this is both a fact, then we can say that this is a fact, but it's conditionally a fact based on these, right? And then this one, so if this one is chatty, then we're like, okay, and if this one, and then interestingly enough, we can check these seedings with like these 5, and we're like, okay, so we just want to make sure that all 5 of these are true. And I think that's fine. Let's real quick look at the queen attack. So I think this one kind of plays to Prolog's strengths as well a little bit. The code did come out, I would say, kind of verbose, but I don't know. So I first said, oh, I made a note for myself. Please do not forget. I don't know why I have a space in there. It's just a typo. Please do not forget that the Prolog variables have to start with a big letter, right? So if it starts with a small letter, then that's an atom. That is not a variable. I don't know if it's convention. I think it's actually something that is required. But anyway. So create, why did I call it dimx? I think that might have been what it was called from the beginning. Yeah, so I guess create is gonna fail if it's not in the board. I ended up using arithmetic equality here. I keep calling it that. I don't. They're saying arithmetic here too, so I don't think I got it from here, but I got it from somewhere. So this one evaluates both arguments and compares the result. This one accepts and evaluates only its right argument as an arithmetic expression. And then triangle was pretty simple, I think. So we just do some like actual comparisons. So is triangle, we have to make sure that the side lengths are okay. And then we classify it as equilateral, isosceles, or scalene based on whether some of the side lengths are equal, right? So if they're all equal, then we say equilateral. And then I said isosceles in these cases. So presumably I could have used semicolons to say or. Honestly, I'd like, actually, this is going to be the last thing before I go to bed. Let me just go back and refactor this. I think it would look a lot better using semicolons. So let's go back. So here, I think we should be able to say S1 or S1, S3, S2, S3, and then get rid of these. I think that would look a lot better. Let's see if it passes. No. 6 tests failed. So much for that idea. Okay, so let's see. Oh, wait a minute. I think I know. Two sides equal S1. I keep doing Q. Oh, it's because my posture's so bad. All right, finish up S2, S3, right? So now we do S1 equals S2. And then I guess these have to be parenthesized. Maybe? Oh, you know what? Did I miss the closing parenthesis there? Okay, hold on. All 22 passed. Okay. Okay. I just missed a parenthesis. It actually shows my state of mind when it comes to prologue. I just think nothing is gonna work. But like also that's just because I'm dumb and keep making mistakes. LFE was a trip for me earlier. Yeah, I like that a lot better. Let's go ahead and do that as a new submission. Okay. So, for tomorrow, what I want to do is going to be vowel count, reversed strings, and who likes it, maybe. I think who likes it is, I remember this one. I think it's going to be quite hard in prologue, unfortunately. Maybe I'll just stick to 8Q. Maybe that'll help me. Prologue really gives me the yips. It's broken my brain, man. Alright, well. So, yeah, these should help me, I think. So, reversed strings in prologue, Boolean value to yes or no in prologue, remove first and last character in prologue. I think that these will help me. And then I'll try to do binary number as a string, I guess. RNA transcription, anagram. Like honestly, I don't know that I'm gonna need to do all of these in prologue. I think knapsack is gonna be the easiest for me in prologue of the 3 that are required. Because knapsack, it's a fairly small problem. But isogram is a pretty small problem also. It's just I don't know how to do string manipulations in prologue. Once I do some of these, like remove first and last